All right, I'm going to show you how to do the 5-4 worksheet now. So let's go ahead and grab it. We'll pull that thing up and we'll go from there. So let's grab it. I got way too many things open here today. All right, here's the 5-4 worksheet. We're going to work through this thing. If you'll look at it, first off, wavelengths, distance from some point on a wave to the same point on the other wave. Most people usually use crest to crest. I'm okay with that. Frequency, the number of waves that pass a point in a given amount of time. Usually a second is the amount of time. You could do waves per minute or waves per hour, but that'd be really slow waves. You're never going to talk about that with electromagnetic radiation. It's always going to be in waves per second. Planck's constant is used to calculate energy of a wave. All right, now there's some mistakes in this next section, I was told. Let's see if that's correct. 5A, radio would have the highest wavelength, or the longest wavelength. The highest frequency is gamma. Highest energy is gamma. It asks for visible color with the lowest wavelength. This should be, the smallest wavelength visible should be violet. So the answer to D should be violet, not gamma. Which visible color has the lowest frequency? That'd be red. And which visible color has the lowest energy? That would be red. That's correct on there. Yep. We good on that? All right, now here's the math. So I took 3 times 10 to the 8th meters per second, and I went ahead and divided this by 100 to get it to 10 to the negative 6. So 3 times 10 to the 8th over 2.6 times 10 to the negative 6 is 1.15 times 10 to the 14th. Okay, quick note. If you have a TI-30 calculator, if you're going to use that times 10 to the n button on it, you have to put all your numbers in parentheses. It's the only way we've been able to figure to get around it. I talked to Mr. Wilson yesterday about it, and he said he thinks the only way you can do it is with parentheses. So please put every number in parentheses on a TI-30S if you're going to use it. And I got on the numbers and E, we could not get the answer they have. I tried and tried. Answer I got was like 7.61 times 10 to the negative 20. Is that what you guys got? Yeah, I do not agree with that answer. Now, the 2 sig figs, yeah, it's 7.6. It's still negative 20th, though. Yes. So, sig fig wise, if we went, I give you plus or minus 1 sig fig, so to 2 sig figs, that's the same. That's the same. Okay? How many math problems are going to be on a test? There's going to be 1 of each kind, guys. There's going to be 3. There's going to be a calculated frequency. There's going to be a calculated wavelength. There's going to be calculated energy. Typically, what have they been on the other tests? 3 points each, 4 points each. That's 10% of the test. Okay? So make sure you can do it, because that's a letter grade. The math is a letter grade. So make sure you can do it. Like I told the other classes, I'm there because we have 2 days. Guys, there'll be a study session at 7 tomorrow a.m. There'll be a session on Thursday at 7 a.m. Excuse me. There'll be a session Thursday at 7 a.m. and one Friday at 7 a.m. So I'm always here at 7 a.m. So come by. And you guys have not taken advantage of it. First class I've ever had, ever. I've had very few of you come in. And trust me, your grades are not showing that you don't need it. So I'd be coming in if you're stuck on stuff. A little extra oomph doesn't hurt to do that. So you're not as smart as you think you are. Most of you. You've been told a lie. So number 7. Once again, I divided by 100. I got 10 to the minus 7th. So I got 6.1 times 10 to the 14th hertz. The answer wasn't there this time. I multiplied that frequency times the Planck's constant. I got 4 times 10 to the negative 19th. Now, guys, look, let's say you can't do this part. Let's say you do this part wrong, but you carry this answer into this problem and work it. I'd give you full credit for this one if you use this number you got that was wrong here. I'd still give you full credit here. Okay? So if you take this answer and you get it wrong, but you put it in this problem and get this, yeah, I could mark you wrong twice, but I won't. If you use the right equation with the wrong number, I'd still give you credit. All right, 8. I ended up with 6.25 times 10 to the negative 8th meters. I went ahead and converted it to nanometers. You don't have to do that. It didn't say to. But if you did, I got 62 nanometers. What kind of a wave is this? Now, I went to the electromagnetic spectrum chart. There'll probably be one printed on a test. I looked up the wavelength. I looked up the wavelength on the chart, and it was in the ultraviolet. It was right on the line between ultraviolet and X-ray. Do you guys agree? I thought it was right between X-ray and ultraviolet. So yes, sir, Sam. Yeah, we'll give you plus or minus 1 sig fig. So, yep, if you rounded that to 6.3, that'd been fine. I went ahead and stuck that answer into here, the one they gave me, and I got 3.18 times 10 to the negative 18 joules. You agree with that? Check me, see if I missed any, because I went fast on these. All right. Barium nitrate. This one I got 5.22 times 10 to the negative 7th. And 3.81 times 10 to the negative 19th joules. Yes, ma'am, Grace. Yep. Yep, you're right, because it was 2 sig fig, so 3.2 should have been the correct answer. You're exactly right. Yeah, that should have only been 3.2 times 10 to the negative 18 by sig figs. Agreed. Wholeheartedly. I didn't catch my sig fig there, did I? We're looking good here. Now, here's where people got caught on number 13. Look on number 13. Nanometers. So first thing I had to do was take this number and divide by 1 billion. If you take this divided by 1 billion, you get 6.5 times 10 to the negative 7th. So now this divided by this came up 4.6 times 10 to the 14th. Multiply those two together, I got 3.06 times 10 to the negative 19th joules. And Grace, yeah, 3.1 times 10 to the negative 19th. Because this only had 2 sig figs, I agree. So 3.1 times 10 to the negative 19th would have been correct. All right, here we go. Fill in the blanks. What type of wave is just slightly lower in energy than visible? Infrared. Is its wavelength higher or lower than visible? They would be lower. They would be smaller. No, they'd be higher. I'm sorry, they'd be longer. They'd be bigger. Yeah, thank you. See, I got that wrong, and then I had to change it. Is the frequency higher or lower? Well, the frequency would be lower. Then above visible is ultraviolet. That would have smaller wavelengths and higher frequency. And if you weren't here when we went over the notes, there's the answer to there's the wave drawn in with the parts. God, it's a terrible wave I drew. That wave actually changed wavelength, didn't it? Ugh. Yep. What do you want? Okay, that's it in a nutshell, folks. Of course, you can speed up, slow down, reverse, go in any order you want. All the problems are worked out there. Watch the videos. Study sessions at 7 a.m. See ya, and hope you enjoyed your PSAT.